Alright, for my last set of data, now I'm going to take my last mass. This is the next set of pennies that I'm going to add to the car. Now, the car weighs about 30 grams. The first set of mass weighs about 30 grams, making it 60, and now this is 90. And partly the way I've done that is because I'm a freak and I like to think about things doubling in mass so it's nice and linear when we look at a graph later. So I'm going to take a moment to take this on here. Again, might change the aerodynamics of the car a little bit, but now we have a car that has, or an object that has 90 grams of mass. We're going to keep our starting pullback force the same, one click, and we're going to get ready to take our first set of data for mass 2. 3, 2, 1, go!
Trial 1.
Trial 2, 3, 2, 1, go!
Trial 2.
Trial 3, 3, 2, 1, go! Trial 3.
Trial 3.
Trial 4, 3, 2, 1, go!
Trial 4.
Trial 5, 3, 2, 1, go! Trial 5.
Trial 5.
Okay, now that we're finished, we can start to process our data a little bit. The first thing we're going to do is start to calculate the average. We're going to use that average time for each trial. That becomes t. And that's important because the whole purpose of this was to collect some times, so now we can work out velocity 2. Velocity 2 is our distance, 1 meter, divided by the average time for each of those masses. So we're going to end up with 3 different times: the average time for the car, the average time for mass 1, and the average time for mass 2 added. Now that you've calculated your data, it's really interesting to see that we now have an average number for each of those trials. And I love this part because I think about, well, why did I get different numbers every 5 times? If I did this 10 times, would I get 10 different numbers? If I did it 20 times, would I get 20 different numbers too? As we saw, we got a couple of numbers that were exactly the same. Now, if I've kept everything else the same, why am I getting those different numbers? So where did our errors come from? What were the things that we kept the same? Our independent variable. What was the independent variable in this investigation? What was the dependent variable? What changed? Okay. What were we looking for? Now, overall, we were looking to see, did a change in the mass affect the change in acceleration? Did it affect the change in motion? And our data is going to really tell us a lot here. Now, obviously, we can look at our numbers and go, our brain's going to cheat and go, yeah, it slowed it down. But there's a few other ways we can look at this. Did a change in mass affect the change in velocity? Or did a change in mass affect a change in the amount of force? You may have noticed that our Lysol carton here maybe was moving throughout the investigation. I kept having to move it back. And did I make sure that I started my stopwatch at the same time that I pressed it? Maybe I didn't. So the reason we take an average is to kind of like negate all of those teeny little errors, and the more data we have, the better. Now, let's go and process our numbers and put them into a chart, and let's see what the data shows us.